Okay, so today we are reviewing for the major quiz that is on Wednesday. Just a reminder, everybody needs to be present in class on Wednesday for the quiz. You have to be here in person to take it. So I have two different reviews. So this is the review I gave you on Friday. I sent it out on Friday, but then if you came to class on Friday, I gave it to you on Friday. We're going to go over that in just a little bit. The first thing I want to do is this one. We're going to do this one all together. If you are on Zoom, this is posted on week 7 documents. I posted it this morning. So you can pull it up there, or you can just copy this on your own paper as you take notes. If you can do this review and this review, you will be prepared for the exam for sure. So we are going to start off with the in-class review, doing that one. So look at problem number 1. It says solve using the square root property. What's your name? Okay, thank you. So solving using the square root property. Look at number 1, x squared plus 7 equals 0. How am I going to solve that one using the square root property? Yeah, you got to move the 7. This is the square root property is where you're like getting x by itself and then just taking the square root. So I'm going to move the 7 first. So subtract 7 from both sides. And I get x squared equals -7. And then how are you going to solve for x, or solve for x from there? Yeah, square root both sides. Don't forget about your plus or minus. So I get x equals positive or negative. It's the square root of -7. I can't take the square root of 7. I can't even simplify it, but I can take out the negative. How does the negative come out? As an I. Okay, so that's going to come out as an I square root of 7. And that's going to be your answer. How many answers do we have there? 2 answers. One is positive I times the square root of 7. The other is negative I times the square root of 7. And if we connect that with what you're doing in college algebra, y'all learned about quadratics. That's a quadratic function. These solutions you just found are technically the x-intercepts on the graph, right? And so that would be imaginary x-intercepts, so that like you would actually have x-intercepts there. Okay, look at number 2. How am I going to solve that one for x using the square root property? Yeah, you got to square root it first here because everything on the inside is all squared. So the first thing I'm going to do is take the square root of both sides. Don't forget your plus or minus. So I get 4x plus 9 equals plus or minus the square root of 8. 8 can break down into 4 times 2, which is 2 times 2. So it's 3 2's there. So it's like 2 times 2 times 2. What can come out? A pair of 2's can come out, right? So you write it on the outside. So it's going to be a 2 on the outside times the square root of 2. So it's plus or minus 2 times the square root of 2. And then from there, I'm solving for x. How am I going to solve for x? Move the 9, subtract 9 from both sides. That's going to go up in front of the plus or minus sign. So I get 4x equals -9 plus or minus 2 times the square root of 2. And then how do you solve for x from there? Divide both sides by 4. Do I need to zoom in? Is this too small? Is that better? Okay, so I get x equals -9 plus or minus 2 times the square root of 2 over 4. And the question, can I simplify that? Remember the 3 outside numbers, 9, 2, and 4, all have to divide by the same number. Do all these divide by the same number? No. So that's my answer. Questions about that? Okay, Okay, look at number 3. It says solve the equation by using the quadratic formula. Okay, so you're given the quadratic formula on your exam. The quadratic formula, if you need to write it down, it's negative b plus or minus the square root of b squared minus 4ac, and everything is divided by 2a. Okay, so I need to write down what a, b, and c are. What's my a value here? 1. What's my b value? 7. What's my c value? 4. So I'm going to do, I'm going to plug it in now. So negative b, negative 7 plus or minus the square root of, this paper we're doing is over there on that table by the door, b squared. So it's going to be 7 squared minus 4 times my a value is 1. My c value is 4. And all of that is divided by 2 times 1. Okay, so I gotta figure out the number inside the square root. 7 squared is 49. Negative 4 times 1 times negative 4 is negative 16, so that's minus 16. 49 minus 16 would be 33. So that's the number in the square root. So this is negative 7 plus or minus the square root of 33 over 2 times 1 is 2. And from there, you check your square root. Can I take the square root of 33? No. Can I break it down? I mean, it's 3 times 11, but can you take anything out there? No. So you're finished. There's 2 answers there. One of them is negative 7 plus the square root of 33 over 2. The other is negative 7 minus the square root of 33 over 2. Questions about that? Okay, so remember your quadratic formula, it could turn out looking like this. You could also actually take the square root of that number. When you take this, if this was like the square root of 25, you would then say, oh, the square root of 25 is 5, and then you do negative 7 plus 5 divided by 2, negative 7 minus 5 divided by 2, and get 2 like normal answers. The other option is if this was a negative, you take out an I, right? Okay, look at number 4, solve by factoring. So how do I solve by factoring? Factor, right? This is AC method. My A value is 1, B is negative 5, C is negative 14. I'm going to do A times C. So 1 times negative 14 is negative 14. Things that multiply to give me 14 are 1 and 14, 2 and 7. Which set is going to give me negative 5? 7 and 2. To get negative 5, it needs to be negative 7, positive 2. Is this a shortcut problem? Yeah, A is 1. So it tells us those are my answers. It's X plus 2, X minus 7, or those are my answers in my factor. How do I solve by factoring? Yeah, set both of them equal to 0. So X plus 2 equals 0. X minus 7 equals 0. Subtract 2 from both sides, and you get X equals negative 2. Add 7 on both sides, and you get X equals positive 7. So that's my 2 answers. Okay, so this is a good example that, like, this is not what you're doing. Like in this class, we're finished at this point, but in college algebra right now, those are your x-intercepts. So you would be able to graph this quadratic by going and plotting negative 2 here, 4, 5, 6, 7, a 7 here. So, oh, sorry, it's gonna be a parabola. Does this parabola open up or does it open down? Do you know how to tell? it opens up because your A value is positive. If your A value is positive, it opens up. If it's negative, it opens down. So this is just gonna be like a U-shaped up. And we could get this number at the bottom. What's that number at the bottom called? The vertex, and there's a formula for that, the negative b over 2a. We're not going to spend our time doing it, but you would find out what that vertex is, and then you would graph it, and it would look something like that. Okay, so that's college algebra. So like, I hope you see kind of the connections. Like, we're not doing everything in this class you're doing in college algebra, but I'm helping you with the math that you might struggle with to be able to apply it to the college algebra stuff. Okay, let's turn it over and look in the back. Simplifying a cube root. Okay, so first of all, it's negative. How does a negative come out on a cube root? Not as an I, just as a negative, right? On number 6, that's square root. That's going to be an I. So take like a minute and start breaking down those two. Okay, when you break down that first one, number 5, you should have got -1, 2 times 2 times 2 times 5 times 7. And this is the cube root. So for cube root, I'm taking out groups of 3. So what do I have? What groups 3 do I have here? 3 2s that can come out. The -1 comes out as a negative. So it's going to be -2 on the outside. I'm going to leave a little bit of space. What number is left on the inside? 5 times 7. What is 5 times 7? 35. For your x's, I have 5 x's here. How many groups of 3 can I take out? 1 group of 3, so it's going to be 1 x on the outside. How many x's are left over? 2 x's are left over, so it's going to be x squared on the inside. And then y to the 6th, if I have 6 y's, how many groups of 3 can I take out? 2 groups of 3, so it's going to be y squared on the outside. Any y's left over? No. So that's my answer. Also, if you came in late, you need to turn in your take-home quiz on the back table, or if you're on Zoom, you can email it to me before class is over today. And the major quiz is on Wednesday, so make sure you're here on Wednesday for your major quiz. Okay, look at number 6. Same thing, but this time I'm doing groups of 2. So take a second to break that one down. So I got -1, 2 times 2 times 3 times 3 times 11. And then x to the 4th power. Okay, so here, since it is square root, the -1 comes out as an I. I can also take out a group of 2 2s and a group of 2 3s. So what number is going to be on the outside? 6, 2 times 3 is 6, so it'd be 6I on the outside. And then I have 11 left on the inside. And then x to the 4th, that's 4 x's. How many groups of 2 can I take out of 4 x's? 2 groups of 2, so x squared on the outside. Are there any x's left over? No. So that's going to be my answer. Questions about that?
Does it matter like if your x and I is split?
No. Okay, look at number 7. X minus 5 squared. Can I just square each of those and say my answer is x squared minus 25? No, you can't. What do you have to do? How do you work this one out? Yeah, you have to write it twice. X minus 5 times x minus 5. And then you have to FOIL or distribute or however you want to think about it. So when I distribute, x times x gives me x squared. X times -5 gives me -5x. -5 times x gives me -5x. And -5 times -5 is positive 25. Combine like terms. What's -5x and -5x? -10x, right? So it's x squared minus 10x plus 25 is your answer. Look at number 8. Number 8's an exponent rule. That's the quotient rule. How do you combine those D's? Subtract your exponents. 3 minus 8 gives you -5. So you could do it that way and say D to the -5th power. Can I leave it like that? No, you have to fix the negative exponent. How do I fix the negative exponent? Put it on the bottom and put a 1 on top. That's one way to do it. The other way to do it is instead of doing 3 minus 8, do 8 minus 3 is positive 5, and your answer goes where the bigger exponent is. So it'd be D to the 5th on bottom. Look at number 9. Number 9's a little bit longer problem. I need to distribute my -2 into everything inside that parentheses. So the 2, what's the power of 2? It has a power of 1 right now, right? And so when I distribute that -2 in, I get 2 to the -2. X to the -3 times -2 is positive 6. Z to the 3 times -2 is -6 over y to the -2 times -2, y to the positive 4. Now I have things with the negative exponents. I need to fix those. How do I fix the things with negative exponents? Move them, right? 2 to the -2 is going to move down. Z to the -6 is going to move down. Everything else is going to stay the same. So I'll get x to the 6th on top over 2 to the positive 2, y to the 4th, z to the 6th. And 2 to the positive 2 is 2 squared is 4. So it's going to be x to the 6th over 4, y to the 4th, z to the 6th. Questions about that? Okay, look at number 10. Multiplying complex numbers. So I just treat the I just kind of like I would an X, just distribute it. 2I times 3, it's going to be 6I, minus 2I times 5I, 10I squared, because I times I would be I squared. And what do I do with an I squared? What does I squared equal? -1. So you have to plug in -1 for I squared. You can't leave I squared in your answer. So this becomes 6I minus 10 times -1, which would be 6I plus 10. You can write it like that, or you can switch it 10 plus 6I. Either one's fine. Questions about that? Okay, you have to be able to do those problems on your exam. Look at the review. Here is more examples of those same types of problems. The only thing that wasn't on that paper we just did was like number 17, finding the domain, and then 23 and 24, the degree and descending order. But everything else was like, there was an example of it on that paper we just did. Okay, so real fast, just a reminder, if you want 5 bonus points on your test, you have to do this on a separate sheet of paper. Paper. And it's due on Wednesday before you take your test. Okay, so we have time to go over some of these problems. What problems do you want to go over? Which one? 17.
So it's +5 if we do all of this on a separate sheet of paper?
Uh-huh.
Okay.
Number 17 is finding the domain of the function. So the function is 3 plus 2x over 3x plus 4. Domain is finding what x values am I allowed to plug in? What's the issue here? You can't have a 0 on bottom, right? Because it's a fraction. We're not allowed to have 0 on the bottom. So I need to figure out what number, when I plug it in, I get 0 on bottom. The way you can do that is by taking the bottom and setting it equal to 0 and solving. So 3x plus 4 equals 0. So when you solve that, subtract 4 from both sides, and we get 3x equals -4. To solve for x, just divide both sides by 3, and I get x equals -4/3. Okay, is that my answer? Is that the domain of the function? No, it's the opposite of your answer. My answer is every single number except for this one. This is the number that I cannot have. Okay, so the way you write your domain is every number except for -4/3. You could literally write that out in words. Interval notation is a little bit faster. Interval notation would be -infinity to -4/3 with a parenthesis, union -4/3 to infinity. Okay, Josue wants to do number 19. Number 19 is a distributing problem, -4ab times xa squared plus ya squared minus 3. Okay, so we're going to distribute that -4ab. -4ab times xa squared would be -4. You got 3 letters there, so however you want to put, whatever order you want to put them in. A times a squared is a to the 3rd, and then b and x. Again, you could put b x a cubed. It doesn't matter what order you put it in. Just make sure you have all 3 of those letters. Okay, negative 4ab times ya squared would be negative 4. A times a squared is a to the third, b y. And then my last term, negative 4ab times negative 3 is positive 12ab. And that's your answer. You can't combine any like terms because there aren't like terms. What else? Oh, sorry, 26 and 8. Look at number 26. 26 is 24 a to the 10th, b to the 4th, over 14 a to the 5th, b to the 7th. Okay, so 24 and 14, that reduces to 12 over 7, right? 12 on top and 7 on bottom. I can put the a's together, a to the 10th on top, a to the 5th on bottom. Subtract your exponents. 10 minus 5 is 5. It's going to go on top or on bottom? Top, because the bigger exponent's on top. So a to the 5th on top, b to the 4th, and b to the 7th. If I do 7 minus 4, I get 3. Does it go on bottom or on top? Bottom, because the bigger exponent's on bottom. Okay, so it's going to be b to the 3rd on bottom. And that's your answer. Let's look at number 8. Number 8 is the square root of 12 r to the 9th t to the 12th. I'm going to simplify this. I'm going to break down 12. 12 is 3 times 4. 4 is 2 times 2. So this is 2 times 2 times 3. 9 r's and 12 t's. I can take out groups of 2 here, so I can take out the 2's, put it on the outside. So 2 is going to be the number on the outside. I'm going to leave some space for my letters. And then the number left on the inside is 3. If I have 9 r's, how many groups of 2 can I take out? 4 groups of 2, so it's r to the 4th. How many are left over? 1 r is left over. If I have 12 t's, how many groups of 2 can I take out? 6. So it's t to the 6th on the outside. How many are left over? None. So that is your answer. 2r to the 4th t to the 6th times the square root of 3r. What else? 27. Z squared times z to the 5th over z to the negative 4th. Okay, so z to the negative 4th on bottom. I'm going to move it up to the top to make it positive. So then it becomes z squared times z to the 5th times z to the 4th. And then you can add all 3 of those together. 2 plus 5 plus 4 is 11. So it's going to be z to the 11th power is your answer. Let's do 31. 31 is 3a over b squared. That's raised to the negative 2 power, and then times 6b to the third a over c squared. First thing I need to do is raise everything inside this first set of parentheses to the negative 2 power. Okay, so it's going to be 3 to the negative 2, a to the negative 2 over b to the negative 4, because 2 times negative 2 is 4, negative 4. And then from there, let me go ahead and fix those. Okay, so let me move. We're basically going to flip this whole thing upside down, right? So that becomes b to the fourth on top over 3 squared times a squared. So I fixed all my negative exponents. And now I'm going to write this other piece times 6b to the third a over c squared. Okay, so since it's multiplication, we can essentially just like combine these, right? Like make it one big fraction and see what we can put together. What can you put together on top? The b's, b4 and b3. So this would be 6b to the 7th times a over, I'm going to go ahead and do 3 squared. What is 3 squared? 9a squared c squared. Well, sorry. What else can I do from here? The a's, a on top and a squared on bottom. I need to subtract the exponents. This is like a to the first power. 2 minus 1 is 1. Going to be on bottom or on top? Bottom, because the bigger exponent's on bottom. So it's going to be b to the 7th on top, a to the first power. Oh, I don't know what I was doing here. This is supposed to be c squared. I wrote a to the c. I don't even know. That was supposed to be c squared. Sorry. So c squared on bottom. What about my numbers, 6 and 9? Yeah, it reduces to 2 over 3. And that's your answer. What else? Number 9. Number 9 is adding complex numbers. It is literally one of the easiest problems on this test, and people tend to try to make it a lot harder than it actually is. Okay, so when you add complex numbers, you're literally just combining like terms. Okay, like the problem takes you literally 5 seconds to do. Okay, so look at the 12 in the first parentheses. What can I combine 12 with? 3. What is 12 plus 3? 15. The negative 6i and positive 2i. What's negative 6i plus 2i? Negative 4i. And that's it. That's your answer. People try to distribute this. 12 times 3, 12 times 2. I try to sit here and multiply it. But remember, it tells you you're adding, not multiplying. So you're just literally combining like terms there. Okay, look at number 10. Number 10 is where you multiply and you distribute. Negative 3i times 6 minus 4i. This is where you're distributing the negative 3i. Negative 3i times 6 is negative 18i. Negative 3i times negative 4i is positive 12i squared. Can you leave it with I squared? No, you got to plug in negative 1. So I get negative 18i plus 12 times -1 would be -18i minus 12, or you switch it, -12 minus 18i. What else?
Twenty-three.
23. Okay, 23 asks you to write in descending order and to give the degree. So 2x to the third minus 5 plus 4x to the fifth plus x minus 3x squared. Descending order is where you're putting it in order where the exponents are decreasing, right? So what's the highest exponent here? 4x to the fifth, yeah, x to the fifth is the highest. So 4x to the fifth is going to go first. What's next? Third power is the next highest, so it's 2x to the third, so plus 2x to the third. What's going to be next after that? Minus 3x squared. And then just the x, so plus x, and then minus 5. That's descending order. The degree is the highest exponent. What's the highest exponent here? 5. So the degree is 5. So thinking about your college algebra class, if that degree is 5, is this an odd function or an even function? Odd functions, that means the end behavior goes opposite directions. One goes up, one goes down. How do you know which way does it go? Rises to the left, falls to the right, or does it go this way? Falls to the left, rises to the right. How do I figure that out? Do you remember? Use your leading coefficient. The sign of your leading coefficient. Is my leading coefficient positive or negative here? It's a positive number. So I picked the positive one. Positive one is the one that's like increasing, like positive slope. Which one looks like positive slope? The one on the left or the one on the right? That one, because it's increasing across, right? So this is the end behavior here for this function. How many zeros does this function have? Or solutions or roots or x-intercepts? 5. It's the same number as the degree. It has 5 x-intercepts or 5 solutions. And what's the maximum number of turns here? It's 5 minus 1, so it's 4. Maximum number of turns is always 1 less than the degree. So this is what you should be doing in college algebra. Like I finished this on Friday in my college algebra class. And so you should be able to graph this at this point. Find the solutions or the x-intercepts, put them on your graph. The multiplicity tells you if it crosses the x-axis or if it bounces off of it, touches and turns it. Are you going over this in college algebra? Yeah, hopefully. Okay. Okay, so on your test, you just have to put in descending order and just do the degree. What else? $28. 30x to the negative 7th, y, z to the negative 14th over 3x to the 0, y, z. Okay, so first thing I'm gonna do is move all my negative exponents. So I'm gonna move x to the negative 7 and z to the negative 14. I'm gonna move both of those down. And what about this x to the 0 on bottom? It equals 1. It basically just cancels out. So these are both moving down. So I get 30 y on top over 3x to the 7th, y, z, z to the 14th. From there, the 30 and the 3 reduce to what? 10 on top, right? On bottom, I have the x to the 7th. I can't do anything with that. What about the y on top and the y on bottom? They cancel out. And what about the z and z14? You can add them together and you get z to the 15th power, because 1 plus 14 is 15. And that's your answer. Okay, look at 29. A to the negative 2, B to the negative 5, over C to the negative 11. And it's all raised to the negative 6th power. Distribute your exponent. So I get A to the positive 12, B to the positive 30, over C to the positive 66. Do you have any negative exponents to fix? Can you combine anything? That's your answer. What else? 11. Okay, on 11, we're solving by factoring. X squared plus 11x plus 24 equals 0. This is AC method. My A value is 1, B value is 11, C value is 24. I'm going to do A times C. So A times C is 1 times 24, which is 24. Things that multiply to give me 24 is 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which one's going to give you 11? The 8 and 3. This is a shortcut problem because A is 1. So my factors are x plus 3 times x plus 8. How do I actually solve by factoring? Set them both equal to 0. X plus 3 equals 0. X plus 8 equals 0. Subtract 3, I get x equals negative 3. Subtract 8, I get x equals negative 8. And that's my answer. What else? 16. Yep. It's probably the last one that we'll get to today. Number 16, I get 6, or I have 6 equals negative 4x squared plus 3x. We need to use the quadratic formula to solve it. To do the quadratic formula, all my stuff has to be on one side and the equation has to equal 0. I'm going to move my x's over here to the left-hand side so that they are positive. Okay, so I'm going to add 4x squared and subtract 3x. So I get 4x squared minus 3x plus 6 equals 0. So my A value is 4, B is negative 3, C is positive 6. Plug it in the quadratic formula. So negative B means change the sign of B. So positive 3 plus or minus the square root of B squared. So negative 3 squared minus 4 times my A value is 4 times my C value is 6. All divided by 2 times 4. So negative 3 squared would be positive 9. 4 times 6 is going to be 96. Is that right? I think it's right. 4 times 4 times 6. Yeah. So minus 96. And 9 minus 96 is negative 87. So this becomes 3 plus or minus the square root of negative 87 divided by 8. I can't take the square root of 87. I don't even think it breaks down. It divides by 3. It's 3 times 29, but I still can't pull anything out of it. But I can take the negative out. How does the negative come out here? As an I. So I get 3 plus or minus I times the square root of 87 over 8. And that is your answer. Okay, so make sure you're here on time for class on Wednesday for your next exam in the class. If you want to get extra bonus points on your exam, bring this completely worked out. Every problem we didn't do worked out on a separate sheet of paper and turn that in. I'll see y'all on Wednesday. You too, Kayla.